Okay. Let's jump right in, guys. We are on our last lesson of consolidation. It is 6 out of 6. We are done after this. It's gonna be a bit of a mishmash tonight. We're going to start by looking at that yucky question that Mukubale gave us on Tuesday. And if you have another question, we can also add one in there. And then we're going to finish off the hyperbola and straight line question that we started on Tuesday. We're going to have a quick brain break. And then we might have time to do some trig, and then we're going to actually end this lesson a little bit earlier because we need to chat to you about how next term is going to work and give you some time if you have questions. Okay, so let's just jump right in. So, Mokubale's question. Let me just write it out quickly. It was 3x squared plus 3x plus x cubed plus 1. Well, it wasn't written like that. Let me write it exactly as it was written. X cubed plus 3x squared plus 3x plus 1 all over x cubed plus 2x squared plus x. Okay, and the instruction for this question was to simplify. So we knew we had to factorize. I'm going to be very honest with you. It's a really gross question. It's actually the first time that I have seen a fraction question like this where they've brought in a sum of cubes. But it lands up simplifying to something quite beautiful. So while I stick to my original agreements that it's gross, it is actually quite pretty by the end. Okay. So the thing with grouping, and this was why I sort of didn't want to waste your guys' time on Tuesday, is with grouping, you have to take time. And what I mean by that is you need to take time to group different methods. So you need to like group those two and see if you get a common bracket. And if you don't get a common bracket, then you try and group those two and those two. And if you don't get a common bracket, you try and group. So you like try a whole bunch of different things until you get something that seems to be leading you in a good direction. And that process sometimes takes a little bit of time. So if you're running low on time in an exam, just be aware of that grouping can take time. But the way that these were actually grouped were this one, and then these two. So I'm just going to rewrite it in the grouping order that we're going to use. Okay, and that's all over x cubed plus 2x squared plus x. Okay, now we're going to break this up. If I'm looking at x cubed plus 1, how can I factorize that? How can I factorize x cubed plus 1? Who can tell me? Get your factorizing hats on, guys. What is it? What is it and how can I factorize it? I'm open to all suggestions, right, wrong, somewhere in between. Hit me with your suggestions. How can I factorize x cubed plus 1? No suggestions. Come on. Okay. You know what, Tiama, but I like that you tried something and I appreciate the effort of trying. Good. I like that you tried it. It's not right, but I like that you tried something. Okay. Also, I like that you're trying something there. Okay. X cubed and 1 are both cubed numbers. They're both cubic numbers. They're both cube numbers. Does that help? Sum of 2 cubes. Yes. Good. It's sum of 2 cubes. Okay, and we very, very, very rarely see sum of 2 cubes in a grouping question, but here it is. Okay, when we do sum of 2 cubes or difference of 2 cubes, in the first bracket, we cube root both of those. So it will be x plus 1. Okay, so we cube root both. In the second bracket, we square the first one. So that's going to be x squared. We have the opposite sign to what's in our first bracket and the product of our first bracket. And we square our second term. And that's what we're left with. That is what exactly. Okay, just be careful that it would be the minus 1x, not the plus 1x in the second bracket. It's always going to be this sign is always going to be opposite of the sign in the first bracket. Okay, cool. So I'm going to rewrite that over here. I'm going to have x plus 1, x squared minus x plus 1. And then here, suggestions on how I can factorize 3x squared plus 3x. Good. Common factor. Good, Sino. Nice. What would that common factor be? What's common in both of them? 3x. Good. Okay. So I'm going to take out 3x as my highest common factor. I'm going to be left with x plus 1. Okay. Now, the reason that we could see that this worked is because it gave us this common bracket. All right. And that common bracket means that we're on the right track. As soon as we're doing grouping and we land up with a common bracket, we know we've done something right. All right. Okay. So just to recap, for those who are feeling a little bit lost, what we did here, that's our green. We did sum of 2 cubes. That was our green. And over here, we took out a highest common factor, and it left us with this common bracket. Okay. And that's all over. Now down here, let's just do it in a different color. The x cubed plus 2x squared plus x, we can take out a highest common factor. So I'm going to take out x, and I'm going to be left with x squared plus 2x plus 1. Okay, so this down here was taking out a highest common factor. All right. Now, some advice. If you got this in a test or an exam, and this top numerator part over here was totally throwing you off, you had no idea what to do, that's okay. It happens. All right. Try a few things, but don't waste a huge amount of time on it. If you're doing it for a long time and you're not getting anywhere, sometimes you have to accept defeat in some questions. Okay. But this denominator was an easy thing for us to factorize. Okay. That was an easy highest common factor thing for us to do. And so even in questions that seem really hard and monstrous and we don't know what to do, if there is even one small thing we can do, we should do it because we will get a mark for it. We never want to leave any question completely blank in a maths test or an exam. Okay. So now we're at this point over here. So, oh gosh, I've already run out of space. What we're going to do at this point is we're going to take out that highest common bracket. So I'm going to take out x plus 1 as my common bracket. Okay. And I'm left with x squared minus x plus 1 plus 3x. And all of that is over x squared plus 2x plus 1. And now this is where it becomes quite pretty, because in this bracket, this minus x and this 3x become x plus 1, x squared plus 2x plus 1, all over x squared plus 2x plus 1. And so now this is going to cancel with this. And so my final answer is just x plus 1 over x. And that is your question, Mokakawale. Luandisa, hello. How can I be of assistance?
Good afternoon.
Hi.
I am kind of lost in you see where you labeled common bracket. Yeah, I'm lost on that stage.
Okay, so when we have, so over here, it's difficult to see. Oh, sorry, I think I unmuted you again by mistake. When up here, we've got this over here as one term, and this over here is one term. And we're kind of thinking of it like a highest common factor. This x plus 1 is common in both of our terms. So we land up taking it out as our highest common factor. Think of it as a highest common factor. And then what were we left with? We were left with x squared minus x plus 1. and we were left with plus 3x. So all we were doing was we were taking out that common bracket and writing what we were left with once we took out the common bracket. Hopefully that clears that up a bit. Does anyone have any other questions about this? Mokubale, I would love to hear your thoughts on this. I'd love to hear where you got to on this in your exam. Talk to me.
Good evening, ma'am.
Hi.
Ma'am, I didn't even do anything that is on the board.
No, not even the bottom denominator.
Nothing, ma'am. I got it wrong.
Okay. Okay. Did you
But
just
thank
go
you so
into
much
full
for
panic
taking
mode?
me through.
Does it make sense now?
It does. Thank you so much, ma'am.
You're most welcome. I mean, it's a horrible question, so don't be too hard on yourself.
No problem, ma'am.
Hopefully this ends up helping one of you others at some point down the road if you get a really nasty question like this. Now you know. If you would like a screenshot of Mokubale's question, please take a screenshot, and we will move on from here. Well, actually, before I move on, does anyone else have a question that they would like to ask in addition to this one? Here we go. Unati, hello.
Hi, Mom.
Hi, how can I help?
Mom, I wanted to ask, I have trouble almost identifying different equations. Like, I know how to do them, but I noticed that when I wrote my math cycle test, it was like there was, I think it was a simultaneous equation, but it looked like
Quadratic.
I forgot what that equation's called. The equation with the or in it.
The quadratics, yeah.
Yes, ma'am, it looked like the quadratic equation, but it was a simultaneous equation.
So the one nasty thing with that, Nati, and this is going to just break your heart a little bit. Some simultaneous equations are quadratic equations. So you have to find x and y, but you could actually have 2 x's and 2 y's, which is a quadratic simultaneous equation. So sometimes you're given one, but there is an x squared involved, and they can combine those two questions. So it's very possible that the question that you saw was actually both, and that's why you felt fooled by it. But generally, if there's an x squared, then it's quadratic. If it's just got a single x, then it's linear. But just remember, for simultaneous, it can be both. And Siama, I know I forgot both. It can be both. It's horrible, but it really can be. And in grade 11, most of your simultaneous equations are quadratic. I'm sorry to be the bearer of bad news here, but they just smush those two concepts together. So then you end up getting 2 x values and 2 y values. Sorry, I feel like I've just broken people's hearts. Okay, let's move past this. So work from Tuesday, we were looking at this question over here, and we dealt with A and we dealt with B, and so C was the last one that we wanted to look at. So let's just try and talk this through a little bit. C is saying determine FG, so that's this line over here, okay, FG, if OH, so OH is 1 unit. So I want you to think about what we spoke about on Tuesday. Remember that when they tell us something, that means that we have to use that information. So what are they trying to tell us? How are they trying to help us by saying that OH is equal to 1 unit? How are they trying to help us? What are they trying to tell us? Come on, guys, wakey. I know it's late in your holidays. Yes, good. They're trying to tell us the x value. Okay, so they're trying to say, cool, we know that this distance from O to H is 1 unit. So that means that the coordinates of H must be -1 and 0. That's what the coordinates of H must be. So these coordinates over here must be -1 and 0, that point over there. Okay, and that's telling us our x values. All right, now remember, f is sitting on our hyperbola, which is y equals -6/x, and g is sitting on our straight line, which is y is equal to -x. We now know that our x value is equal to -1. I would like the distance of FG, please. Can you guys please work on that and tell me what my distance is?
Oh,
So quiet tonight. I think everyone's tired. Getting
Yeah.
ready to go back to school.
Probably they haven't been sleeping enough, and now that school's coming, you better start to sleep. That's what I did, at least. Lisa, you'll be okay. These videos
yeah.
are recorded.
Please don't panic. If this is your first lesson, please don't panic, okay? All of our lessons are on the Watobe website. You can watch everything. You can go through it slowly. You don't need to stress.
Yeah, because this is
Okay.
our 6th lesson on this stuff.
After having done a whole course on functions.
Yeah.
It's okay, Andy. Just try and follow when we're talking through things. Okay, so we're getting some answers coming in. We're saying FG is 5 units. Andre's saying 5. Corinne's saying 5. Eric's agreeing with that. Okay. Nice. Let's give it a go. Okay, so I'm just going to write some notes here as we talk about this. F lies on the hyperbola. Okay. And so we can say that this is our hyperbola's equation, and we are wanting to sub in x is equal to -1. Okay, all right. And so we're going to say, what would our y value be if x was -1? So y is equal to -6 over -1, which means y would be equal to 6. So that means that the coordinates of f are going to be -1 and 6. That's what f is going to be. Okay, then we have a look at G, and G lies on the straight line. Okay, so that's going to be y is equal to -x. So we're going to sub in. So the x is equal to -1 comes from this sentence here where they said OH is equal to 1 unit. So they told us that this distance, that orange line that I've just drawn, that is 1 unit. And so the coordinates for H are -1 and 0. Yeah, so quickly, it's the same graph we did on Tuesday. We just didn't get to do question C. So we're just finishing off question C today. Okay, so that sentence was telling us that the coordinates for H were -1 and 0. And so that told me that all of my X values in that straight line would be -1. Okay, so then Y would be equal to -1, which is equal to +1. And so my coordinates for G are going to be -1 and 1. And so if my coordinates for F, my Y is 6 and my G is 1, then the distance between those two, 6 minus 1, is 5 units. So my distance is going to be 5. It's going to be 5 units long. Okay, so this was just looking at distance in a slightly different way. If you combine these questions with some of the ones we did on Tuesday, I think it will be really helpful when you start going through these in class. The other thing is really what I wanted to get from these sort of tougher graph interpretation questions is when you see things like this in the exam, I don't want you to panic. I don't want you to stress. I don't want you to think, I can't do this. I'm not even going to try. I want you to have a little bit of confidence to try a little bit of it. So it depends. Generally, always subtract as long as you're taking the top number from the bottom number. So let's say, let me just draw us a little fake graph over here for a second. Okay. And let's say we had a parabola that was chilling and we had let's do it like that. Okay, and I want to know the distance of that line over there. Okay, let's say this was A and this was B. And the coordinates of A were -4 and 8, and the coordinates of B were -4 and -4. Okay, if I want to know the distance of AB, we just say A minus B. Now we can only do that if they have the same X value. Okay, so both of these have -4. So then I'm going to say 8, because my A value 8 minus -4. So 8 plus 4, which is 12. So that's why it seems like you're adding. Yeah, so, you know, don't panic. Like when you, but the thing is, when you get to functions in class, I really, really recommend you go through our videos where we did functions together, because it really cements everything and it'll make things fall into place a little bit easier. We also go through some sort of normal questions in the beginning. These are just really tough function questions, just to give you a bit of insight into what some of the harder ones are looking like. If they don't have the same X value, we can't do this. We would have to use the distance formula, but they're only going to do that to you in analytical geometry. They're not going to do that to you in functions questions. Yeah, you are. You're going to look so smart. So smart when you do this in class. You're going to be like, actually, I'll just talk the whole class through this. Thanks.
Why is Tim scared for next week Friday?
Yeah, why are you scared for next week Friday?
We're talking about weekends, yeah, supposed to be celebrating.
Yeah, so crazy. Oh, school reports. You will be fine.
That's me tomorrow. So you don't
Linda
know.
gets her school report tomorrow.
Yeah.
Okay, let's do a quick brain break and then we're going to jump into a little bit of trig. Okay, if you'd like a screenshot, you're welcome to take one.
Oh yes, it's your time. Shine. Take a screenshot. It will really help you.
For those of you who are new, a brain break is not anything stressful. It's just something silly to get your brain out of a stress mode, and then we get back into the maths. So if you struggle with it, please don't panic. Tibelihle, hi, how can I help?
Tube, are you still with us?
You just need to unmute on your side. So you should have gotten a notification to unmute.
Yeah, maybe it was a mistake.
Oh, okay. It wasn't. Oh, that's okay. No problem.
Yeah.
Okay, let's jump on to Brian. Okay, so I've done the same things that we did on Tuesday. And it's going to be 3 dingbats. So for those of you who've never done one before, or who this is your very first lesson, a dingbat is a picture, and it's very straightforward. It doesn't seem straightforward, but like when you figure it out, you'll see that it's very straightforward. You've got to figure out what the phrase is or what the word is.
Yeah,
Based
there's
on the
no
picture.
hidden meaning in between. It's just what you see.
It's exactly what you see. Oh no, Mokugubale. Her screen went blank and then it was all of a sudden brain break. Like time just disappeared. I'm so sorry. Okay, so our first question. What is that? What is that? Not welcome. All suggestions, pop them in the chat for me. It's not welcome.
You guys are close though.
Don't give it away, you Linda.
I see you want them to sweat.
I want them to sweat, yeah. Ah, and Paul got it first, and then Ciro, nice. Well done. It was welcome back. Because it's welcome back. Get it? Yes.
Okay.
Because it's saying welcome, but it's backwards. So it's welcome back. Like, welcome back, guys. Okay. Next one.
Let's go, my people.
Not high IQ.
This took the grade.
Q sit, no.
Over
Over Q, no. Quit, no. Jump Q, close. Think of it as like a sentence that you would say. You're very close. Not high jump. No. No. Emile, it's also close. There we go, Emmanuel. Okay. So like it was jump the Q. Oh goodness, jump the Q. Or you could say jumping the Q. Either way is also fine. You could say skip the Q. I would have taken skip the Q. You are jumping over the Q.
It's mistress. To exercise your brain, okay, so that you think about this. Guys, it will
Think
be
about things in a slightly different way.
Yeah, take screenshot. You can play it with your friends or like
yeah, exactly. Like go and
anyone
torture
in the
them for a bit,
family.
guys.
Yeah. When there's load shedding, it's a good game to
Okay. So, you know, that's exactly what I like to hear because that means you've been doing enough maths. It's good. Okay, last one. This is a thing. It's not a, yes, guys, you got it so quickly.
This was so fast.
Oh my gosh. You guys got that so quick.
Yeah, it's just...
Yeah, it's a stopwatch.
So disappointing. This one was really quick.
So quick. So quick. Oh, I had two harder ones and I thought that they would be too tricky, so I didn't put them on, but I'll yeah.
Then you know
Nice.
what's next week harder ones, guys. You heard. Oh yeah, no.
Nice job, guys. Okay,
Fighting
let's jump into some trig questions. We're just going to work for the next sort of 10 to 12 minutes and then we're going to chat about some stuffles. Okay. So what you have in front of you is you have a trig graph. How exciting. The diagram below shows the graph g of x is equal to a sine x for 0 degrees, x must be smaller than 360 degrees. Okay, so first of all, my question to you is, what is this telling me? What is that 0x 360 telling me? So when I see this in a test or an exam, do I panic? No. Good, Emmanuel, it's telling me my domain, okay? All it's telling me is basically what we're seeing here. We're seeing it from 0 to 360. That's all it's saying. Okay, so when we see that, we don't need to panic. We just need to think it's just telling us what we're seeing on this graph. Okay. Now remember, your formula for a sine graph is y is equal to a sine x plus q. They haven't got a q here, which means our q is 0. Okay, so we only have to worry about that a. What does the a stand for in a sine graph? What does the a stand for in a sine graph? Yes, nice, guys.
Well done.
Good. It's the amplitude. Okay, and the amplitude is how high our graph goes. So our very first question here, write down the value of a. What is my amplitude in this graph? Yes, Portia. Like it. Good. Okay, so for our amplitude, we can go from our center point up to our maximum, and we can see that that's 3 units. Okay, so that's one way of finding our amplitude. Another way of finding our amplitude, we have to be careful though. I'm just going to leave some space and you'll see why. Another way of finding our amplitude is we take our max. Okay, so our amplitude would be equal to our max minus our min divided by 2. So our max over here is 3. We're minusing our min, which is -3, and we're dividing that by 2. So 3 plus 3, which is 6 over 2, which gives me 3. Okay. Now, Is my answer just 3? That's my question to you. Is my answer just 3? Is A just equal to 3? What's happening? What's happening to my sine graph? Which direction is he going? Is he going up first or is he going down first? He's going down. So that means that my amplitude must be negative. And so, okay, yes. So amplitude itself, if I'm asking you what is my amplitude of a graph, so what is my amplitude of this, you would say 3. If I'm looking for the A value, which we also use as the word amplitude, we sort of interchange them, which we really shouldn't, because you are 100% right. An amplitude can't be negative, but an A value can be negative. So we kind of interchange those words, and we just need to be a bit careful. So just be aware that your A value can be negative, but you're 100% right. If you're asked just for an amplitude, you're 100% right. That can't be negative. Exactly. Nice. Sine graph always goes up first, and here he's going down, which means it's going to be a negative sine graph. Okay, so just remember, a positive sine graph, if we just drew a normal sine graph, it would look like that. It would go up first. It would go up, and then it would come down, and then it would go like that. That would be our normal one. Yeah, Bukamosa, don't panic. The whole of trig graphs are also all on the website. We did a whole course on them, so they're all there. Okay, and I think we made them quite fun. People seem to enjoy them, so I think you'll be fine. All right, what is the period of G? Yes, woo! Okay, the period of G is 360
That's
degrees.
amazing.
And Siama even had that unit in there, which just made my heart happy. Yes.
You know, 100%.
Okay, so for our sine and our cos graph, it's going to be 360 degrees. What is our period for a tan graph? $180. Good. Yeah, 180 wheels of cheese. Okay, and can someone explain to me in words what a period is?
Oh, let's go, my people.
Not the biological period that women have to deal with monthly. What is mathematics? Like
Oh,
mathematics
definitely not that one.
is our definition of a period. Good, it's our full curve. So it's how many degrees does it take for the full curve to happen? So from there to there, my full curve has happened. From this point, it's going to go back down again. Good. So it's how many degrees it takes for that full curve to happen. Great. Okay. 1.3, nice and easy. Write down the coordinates of the minimum value of G. So what is the smallest value that my graph is? What are the coordinates of my minimum value? And they want coordinates. Yes, just be careful, Lolelo. They asked for coordinates. Yes, okay. So my smallest value is down here. That's at 90 degrees and at -3. Good. Okay. Now we get to the fun question. If the graph of G is translated 2 units up to form a new graph H, write down the range of H. Okay, so we're going to do this in a little bit of a sideways way. The first thing I'm going to say to you is, what is my current range? What is my range of my graph that you can currently see? What is this one's range? This graph's range. Remember, range are all my possible y values. Good, Emmanuel. We're going to put it in brackets, but it is from -3 to 3. Okay, good. Good. Okay, now let's read what this question is saying. It's saying that this graph is translated 2 units up. So tunnel weighted, we're going to use square brackets because it is allowed to be -3 and it is allowed to be 3, which means it's allowed to include them. So that's why it's going to be square. If I'm moving this whole graph up by 2 units, can you think about what my new range would be? What is my new range going to be? Yes, guys. This
Well
minimum
done,
value is
my
going to be -1, and this maximum value is going to be 5. Beautiful. And you guys just got 5 marks of trig functions in your pockets.
Give it back. You nailed it.
Yeah. Trig functions should be your friends because they're these types of questions that people see and they panic and they freak out and they just leave them out. But actually, they're not that tough. It's all the same sort of questions. So as soon as you've done a few of them, you actually can do most of them. Okay, let's do a couple extra questions, then we'll move on. All right, so for these ones, oh, it's okay if you haven't done trig functions yet. Remember, you can, no, this isn't in the quiz. I'll explain that all later. All of the trig function videos are online, so don't panic. Okay, some nice, easy trig equations. So go and grab your calculators for me. And let's see if anyone can talk us through how to find the answers to these. Yeah, you can take a screenshot. Let me just quickly pop up. Here we go. Okay. Yeah, Zandasile, great. That's a perfect start. Okay, so we're going to divide both sides by 5. So we're going to say cos x is equal to 3/5. Where do we go to from here? If I'm trying to find my answer to x, where do I go to from here? If I'm looking for an angle. Yes.
Well
We
done,
use
guys.
shift. Okay, when we're looking for, oh goodness, when we're looking for an, it's like erased half of it. Okay, when we're looking for an angle, we use shift on our calculator. Okay, so basically what we want to do is we want to isolate our trig ratio with whatever's next to it, and then we're going to use shift on our calculator. So now in our calculator, we're going to push shift, then we're going to push cos, and so now in your calculator, it'll look like this. It'll say cos -1 with brackets. In that bracket, we're wanting to put the fraction that we have. So we're going to push our fraction key, we're going to push 3, and we're going to push 5, and then we're going to push equals. We'll close your bracket and equals. And then you can all tell me what my value for x is going to be. Okay.
Let's do this. Do they normally tell them like what they have to round it off to 2 decimal places, or?
Yeah, so if they don't tell you in the question, then it's going to be 2 decimal places. In this question, they said correct to 1 decimal place. So we're going to round it off just to 1 decimal place. And we're looking for an angle, which means my unit is going to be what? Degrees, good.
Well
Okay.
done, Manuel,
Nice.
well done.
Okay, cool. Let's give this one a go. So you can kind of just talk me through this one. What would be the first thing we would do in this question in 2.1.2? What would be the first thing we would do? Good. We're going to move that 1 over. Okay. So we're going to have tan 2x is equal to 1,19. Now our trig ratio is isolated. Okay, so at this point, we're now going to go into our calculator. So now we're going to say shift tan 1,19 equals, and you're going to tell me what you get when you do that. and don't round it off. So write down an answer with at least 5 decimal places. Cool. Okay. Now, what is that equal to? Because that's not equal to x. What is that equal to? That 49,95845, blah, 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 blah. Good. It's equal to 2x. Okay. So now if I'm wanting to know the value of x, what would I do from here? Good. I'm going to divide by 2. Okay. So basically, I'm dividing both sides by 2. And now I can round my answer off to 1 decimal place. So divide that whole answer by 2, and then give me an answer that's broken down to 1 decimal place. Oh, I thought I had you guys tricked. Nice. 1 decimal place, which means because they specified 1 decimal place, even though that comma 0 seems so silly, but because it was specified, we have to give 1 decimal place. So 25,0 degrees. Nice job, guys. So proud of you. You did really well.
Well done.